curriculum in Math 1. In fact, that's about half of the curriculum in Math 1. But then we do a little review of it right here, smack dab in the middle of Math 2. So let's see what you can remember and what we need to relearn. Grab my glasses here. It feels like they remember some of it from last year, and I'm not going to call on you to answer questions. I'm just kind of curious what you feel like you remember.
I don't know.
We don't know what we remember yet?
I forgot.
It seems familiar.
Feels familiar? Okay. Exponential functions, we've got something, and we're raised to a power. And that raised to a power is what takes us from like a linear equation. When we have x squared, it gives us a parabola. And in this case, we've got something times a base raised to the exponent, and it gives us a curve because our x, our variable, is the exponent. So that's what gives us that curve. So let's see, the base b is a constant, so it's some number. Some number. A can't equal 0. The exponent x is a variable, and x is any real number. That means it can be positive, it can be negative, it could also be 0. Okay? And for the most part today, we are going to graph these by creating a table. And I'll actually show you how to do some of your homework as well. So they've already got this set up for me. -2, -1, 0, 1, 2, 3 are the numbers that they want us to plug in. And you'll find today that your homework, I think, we'll just have you do -2 all the way to +2. So grab your calculator, is how we'll do this. And if your base is a negative number, like my base in this one is +2, but if my base was a -2, you have to remember to put that -2 in parentheses. Oops, you can't see my calculator. Before you raise it to the exponent. Okay? But in this case, we have a positive number, so we're good. So they already figured out 2 raised to the 1/4, -1. Whoops, 2 raised to the -1. How are they getting fractions? Well, let's look at it. If I do 2 raised to the -2, what does it give me? 0.25. If I want to see it as a fraction, I go math, enter, enter. There's that 1/4. Over here on this table, we're doing 2 raised to each value of x right here. We're just creating a table. So what's 2 to the 0? Anybody remember that without typing it in? Not 0, it's 1. All right, now I'm not going to need my calculator for the rest of these. 2 raised to the first. 2 raised to the second, and 2 raised to the third. When you plot those points, -2, there's that, 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 and that. All right there on that curve. And it will ask you today what your domain is and what your range is. Do you guys remember how domain and range works? Because it's been a minute since we've talked about domain and range. Domain.
Isn't that domain the x and range the y?
Domain are your x values. And the range are your y values. And so then I've got to look at this graph. Anywhere on this x-axis right here, let me change colors. Anywhere right here on this x-axis, could I go up and find my function? Like even if I was over here, could I go up and hit my curve? Pick a number clear over that I be able to intersect my exponential curve? Yes. Is there a number on the x-axis that I could pick that I could not run into it?
You would eventually.
I would eventually, even if it was clear off the chart up high, which is going in that direction, I would still eventually run into it. Every number of x. So the domain here is all real numbers. All real numbers. And the way we say that is x is all the numbers between negative infinity and positive infinity. You're going to find that my domain is pretty predictable when it comes to our exponential functions. The range, though, let's talk about it. So range is the y-axis. This is what I'm looking at. Is there anywhere on the y-axis that if I was to draw an arrow that I would not run into
Any negative values? Because it's important, is it going up?
all right here? Is she right? I should have drawn that arrow over there. Down here, is there any function down here? No function down there. So no negative values. What about 0?
Well, that would just be one. That would just be one.
Can't tell, but let's talk about this. Let's go back to our table. If 2 raised to the negative 1 is 1/2, 2 raised to the negative 2 is 1/4. What's 2 raised to the negative 3? 1/8. To the negative 4, what is it? 1/16. And then 1/32 and 1/64. Am I ever going to reach 0?
No.
Never. I'm never going to reach 0. So this function actually has what we call an asymptote. And I don't know if you graphed with asymptotes last year or not, because Math 1 isn't something I teach. Does that sound familiar, that vocabulary word?
No.
All right. So asymptote. Whoops, I left out the P. Let's try that again. asymptote. Asymptote.
I think you introduced it to us, but we never used
He probably did introduce it to you, I think. An asymptote is a line the function gets closer to,
Never reaches.
but never reaches. A line the function gets close to, but never reaches. So this one actually has an asymptote at 0. So our y equals 0 is an asymptote. And that lets us see that our range, y can't be 0 or negative, so y has to be greater than or equal to 0. Let's erase this mess here. Can I move that over? All right. Example 2. All right, let's make sure you know how to use your calculator. Tell me what 1/2 raised to the negative 1 is. Let's make sure we get the same answer in our calculator. 1/2 raised to the negative 1. They've already figured out -3 and -2 for me. I don't know, is it? Did you figure it out?
2?
Yes.
2, yes.
1/2. There's my 1/2. I could have used the fraction button too. Whoops. Can we see it? Is it coming? There it is. 1/2 raised to the negative 1. What does it do? Gives me positive 2. So.
You don't even got to do parentheses.
Yeah.
I don't. I did. I had 2 the way I typed in my fraction.
Yeah.
Or I would have just had the 2 raised to the negative 1.
So I just did 1 divided by 2.
And then it worked. Okay.
And plus, could you consider order that it's just basically going up in
You can. So you're looking at your pattern right here, yes?
in the pattern.
So what is 1/2 raised to the 0?
0, 1,
1. 1/2 raised to the 1. 0.5 or 1/2. 1/2 squared.
1, 1, 4.
All right. Could I have just done half, 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 half? For sure. Plot those points. I know this is kind of fuzzy, isn't it?
Well, this one's going to be the opposite direction of the last one
Why is it the opposite direction?
because the numbers are descending, but are opposite them with the.
Why do you think they're descending though? That's the important question. Why do you think they're descending?
Because we're multiplying a fraction.
Because we're multiplying a fraction. That's exactly why. That's exactly why. All right. We took a long time talking about our domain and range on the last one, but that means that this one's going to be a little bit quicker for us. What is the domain? All my x values. And I always intersect the function. So all real numbers, we can say x is in between negative infinity and positive infinity. Where's my asymptote on this one?
0.
Yeah, again, it's a 0. So what's my range?
Y is greater than 0.
Y is greater than 0. It's always going to be greater than that asymptote.
So what was the range on the last problem? I didn't get it.
Same thing. Y is greater than 0 because it doesn't exist down here in the y negative area. All right, let's see what's at the bottom of this worksheet because I'm not sure what it is. Properties of exponential functions. The domain is our x values. The range is our y values, and in the case over here, what happens? Y is greater than 0. Where do they have y-intercepts?
At 2. It has y-intercept at 2.
Yeah, I don't know if I like that. All right. Okay, when b is greater than 1, which way does my function go? This way. When b was a fraction, what happened to it over here?
It went up left.
Okay, it went up on the left. And where do these have asymptotes at?
Near 0.
Yeah, y equals 0. Now, I do want to show you a couple of your Alex problems because they present it in just a little bit of a different way. So let's just make sure we've got it. Let's see. These first problems, all it wants you to do is create the table. If you find that you're not getting the right answer on these right here, that means you're not putting it in your calculator correctly. And if that's a problem for you, let me know. So these first couple, all it wants is fill in the table. Bam, done. So then let's look at, I'm going to fill in the table, let's see. Okay, graph. So we've got to create our own table here, and it wants how many points? 5. You can't graph it unless you use all 5 points. You're going to want to create your own table. -2, -1, 0, 1, and 2 are the x values that you're going to want to use here. Anything bigger than that, and it will end up going clear off of the graph. And you don't want to do that. What was my function? I went right by it and was trying me scroll down. So we've got 4 to the x. All right, let's do this. What is 4 raised to the negative 2? Should we start down here? Let's make it easy, and let's look for our pattern. What's 4 squared? 16. What's 4 raised to the first? 4 to the 0. All right. What's going on here? Have we got a pattern yet? We're always dividing by what?
-4 and then.
Raising to the, okay. So we are dividing by 4, aren't we? So if I know my pattern, now I don't really need to grab my calculator, because what's this divided by 4? 1/4. What's this divided by 4? Okay. Now, here's the big question. I have to know how to graph those points. And I don't know how much we've used this tool in Alex, and this was part of the reason I wanted to show it to you, is you've got to grab that tool right there. Do you see where it was? This tool right here is plot a point. And then you can type in, our point is -2, and then over there it was 1/16. And look, the point showed up right there.
Wow, that's amazing.
All right, and then I'm going to have to do it again. All right, let's see, go away. How are we going to do this? Oh, it didn't graph it for me. Why? I didn't plot the point. All right, -2. Don't make the same mistake I did then. Remember to plot point. And then I've got -1, and I have 1/4 plot point. You could keep doing that, but now I honestly think it's easier to just grab those. There's my 0, 1. No, it wasn't. There's my 0, 1. Here's my 1/4, and here's my 2. That was nice of them that they went all the way up to 16. Now this is one of those things that lets you double check. If it doesn't give you that nice, pretty smooth curve, it's telling you you did something wrong. And you need to go back in and figure out what that is. So if you don't get that nice, pretty smooth curve, you did something wrong. And let's see. And also draw the what? The asymptote on this one. Let me rewrite this down here. Y equals -8 fifths x. X, Y. Then I can come down here and see my whole graph. Okay, so this isn't quite as pretty to figure out. So you're going to grab your calculator and make sure when you enter this in that you've got the negative and then the parentheses. If you don't, it messes it up. What's up?
Nothing.
All right. So on, let's see. -8 fifths raised to the -2. Math, enter, enter. I get -25/64. Aren't you glad you don't have to plot that one by hand, that we can type it in? Raise the -1. It's going to be -5/8. Raised to the 0, what's it going to be? 1. This part would be 1, but then that makes it -1. Raised to the 1 would be -8 fifths. Raised to the square would be negative what? Square 64 25ths. Good. Yuck. So on that one, are we going to use that point plotter for every single one of them? You're okay graphing that one? We'll grab it right now. All right, there's 0, -1. All right. So then we have -2 and, goodness gracious, -25/64. Plot the point. We have -1 and -5/8 plot point. We have 1 and -8/5 plot point. Ooh, which way is this going?
Up to the
And we have 2 and -64/25.
going down.
Why did it go down?
Because it's negative.
That's exactly why. Because it's a negative function, that's what makes it go down. All right, I can connect the dot. Nope, it wants the asymptote first. Where is my asymptote? Where is that line that it crosses or gets close to but never crosses?
0.
Yeah. Soon enough, we'll be moving that asymptote, but we'll save that for another day. So once you plot your asymptote, you can connect those dots, and there's your beautiful function. All right, I hope some of that reminded you what happened last year. Your mind exploded?
Yeah.
Why did it explode?
I did it.
Yeah. All right, we'll have to work
Will it
together on
always
it.
be like backwards? So like, would you even have to do the, like say you did the positives, would you even have to do the negative?
If you can see the pattern, no. The pattern is key, if you can see it and follow
Well,
it.
the last like 3 problems we did, they just reflect except for it's backwards.
Yep. So, good job. You are correct. Oops, I'm gonna need my mouse so I can stop the video.